Hi everyone. In this lesson, we'll talk about arrays and their operations like insertion, deletion, and traversal. So let's get started. Arrays allow us to store multiple data of the same data type within a single variable. For example, this array allows us to store integers. The data stored in an array is called the element, while the position of each data is called the index. Arrays use zero indexing, where the first element is stored at index 0. The next element is stored at index 1 and so on. Now let's create arrays in C++. To create an array, we first write the data type of the array, followed by its name. Then we specify its size within square bracket. Arrays are a static data structure, so we should always specify its size. Finally, we assign a set of values using curly braces. For example, let's create a food array of strings. Let's create a character array of alphabets. One major problem with arrays is they cannot store data of different data types. I will try to stick a number within the food array. We can see that the compiler shows an error. Now let's try to print an array. Now let's run this program. So what's this? Well, when we try to print an array, it actually prints the address of the array. However, we can print the individual element of an array using its index. Numbers of 4 will print the last element of the numbers array. Now let's use an enhanced for loop to print an array. Now let's run this program. We can see that we can print the individual element of an array and also the full array using a for loop. We can also modify an array using its index. Let's modify the third element of the numbers array. Now let's run this program. We can see that the array is modified. Though arrays are a static data structure, we can make them somewhat dynamic by getting their size from the user. Now let's create an array using this size variable. So what's wrong here? Well, we cannot use a variable directly inside the square brackets when declaring an array. We can use constants, which are variables declared using the const keyword, but not resizable variables. That's because array sizes must be known at compile time. So to create an array whose size is decided at runtime, we need to use the new keyword to dynamically allocate memory. The new keyword dynamically allocates memory and returns a pointer so that the type of the array should be a pointer. Now let's modify this array to be dynamic. Now let's use a for loop to initialize the array. Now let's print this array. Now let's run this program. Let's give the size as 5. First element, second element, third element, fourth element, and fifth element. We can see that we can create somewhat dynamic arrays by using the new operator. To overcome the static nature of arrays, C++ provides another data structure called vectors. Vectors are basically resizable arrays. They can automatically resize themselves when you add or remove elements. Unlike normal arrays, you don't have to worry about declaring their size beforehand or using the new keyword. You simply create a vector and it grows or shrinks as needed. Before creating vectors, we need to first include the vector header. Now let's create an vector of integers. Now you might have noticed something weird in the syntax. What's this int part? Well, that's where C++ templates come into play. For those who are not aware of templates, it lets you create a vector of any data type. We can add new elements to one vector using the pushback operator. Vectors can be accessed in the same ways as arrays, using their index. Now let's use an for loop to print this vector. Now let's run this program. We can see that we can use vectors to create dynamic data structures. Now let's talk about some operations of arrays like insertion, deletion, searching, and updation. To insert a new element in an array, we move the previously added elements to the right before inserting the new value. For example, to insert a value 25 at index 2, we move the previously inserted elements 30 and 40 to the right. Here I have given the algorithm for inserting a new value. We first increment L, which is the index of the last inserted element. And then we assign the loop variable j to L. And then we keep moving the element before j to the jth index until j is less than k. For example, to insert a element 25 at index 2, we first increment the index of the last element to 4. And then we assign the loop variable j to L. And then we take the previous element to j and that assign it to the jth index. And then we decrement j. We can see that the condition is still not satisfied. K is still less than j. So again, we'll add the previous element to j to the jth index. Now we decrement j. We can see that the condition is now false. K is not greater than j. So we insert the new element at the jth index. In C++, we cannot perform insertion in raw arrays. However, we can do the same in vectors using the insert function. Let's insert a new element at the third index. This line numbers.begin might look a bit strange. Here, begin simply points to the first element of the vector. By adding 2, we are telling it to move 2 steps forward. That's where our new element will be inserted. Vectors provide a function called size, which returns the size of the vector. Now let's run this program. We can see that the elements have moved to the right and the new element is inserted. To delete a value from the array, we first remove the element and move all the remaining elements to the left. Here I have given the algorithm for deletion. We first assign the loop variable j to the position of the element to be deleted, which is k. Then we assign the value next to j to the jth index until j is less than 12. For example, to delete the element 30 at index 2, with the last element at L is equal to 4 index. We first assign the loop variable j to k, which is 2. And then we take the element after j and assign it to j, which is 40. And then we increment the loop variable. We can see that the condition is still not false. So we take the next element and assign it to j. And then we increment j. We can see that the condition is now false. So we get out of the loop and then we change L as 3. This is how we perform deletion in arrays. We can perform deletion using the erase function in a vector. Now let's run this program. We can see that the element 45 is deleted. We can update an element using its index, which we have already done before. Searching in arrays can be performed using linear and binary search algorithms. I will talk about linear and binary search in another series called algorithms. Until then, stay tuned for future tutorials.